Hi dear viewers, my name is YasTech and welcome to my YouTube channel for the tech related videos. In this video, we are going to discuss a very interesting topic in networking and data communication, which is known as network architectures. Before moving ahead in this video, please don't forget to like, subscribe and hit that bell icon so you never miss any update. It is necessary to understand about the structure and the working of the network that you are using in your daily life. If you don't have any idea about it, then you are about to discover it in this video. This video provides a comprehensive overview about the network architecture, the types of network architecture, their working procedure, advantages and disadvantages with some real life examples. So first, let's get started with the definition of network architecture. Let's break down a key concept in the world of networking, network architecture. It defines the layout or structure or framework of a network. Network architecture is the design and layout of how computers, devices, communication media are structured to connect and share information. It is like the blueprint of a city, but instead of roads and buildings, it maps out how data flows between computers, routers, switches, servers, and other devices. It defines everything from how devices are arranged to how they communicate, what protocol they use, and how data is transmitted securely and efficiently. There are two main types of network architecture. The first one is known as client-server architecture, where one powerful device, the server, provides services or data to the many other devices known as clients. In peer-to-peer architecture, where all devices are equal and share resources directly without having a central server. The concept of client-server architecture can be well understood by looking at the real-life example. Imagine a busy library where readers walk in, searching for different books. The readers are like clients and the librarian at the counter is the server. Every time a reader wants a book, he asks the librarian and the librarian finds it and hands it to her. This is exactly how client-server architecture works in the digital world. In client-server architecture, we have two key players. The client, usually a computer, phone or application, which sends the request, and the server, which is more powerful system at the center, processes all the requests and responds with the required data or service. The beauty of this setup is that multiple clients can connect to one server at a time. The server handles all the communication, ensuring every client gets what it needs. But there is a catch. If the server goes down, all the clients are affected. Still, this architecture is widely used because it offers centralized control, better security, and easy management. So next time you load a website, just remember your client making a request and somewhere a server is working hard to fulfill it. Now we are going to discuss the example of client-server architecture in context of Gmail. Let's suppose when you open your browser and go to the gmail.com, your computer or smartphone acts as the client. It sends requests to the Google Gmail server asking to log in and show your inbox. This request travels through the internet, passing through the routers, switches, and data centers until it reaches the Gmail server, which is managed by the Google. The Gmail server receives your request and checks if you have valid user by verifying your email address and password. If everything checks out, the server processes the request and sends back a response which includes your latest emails, folders, attachments, and all the information displayed in your inbox. This response travels back through the network and reaches your device. Your browser then displays your Gmail inbox in a format you can interact with. And the process doesn't stop here. Every time you click to open an email, send a message, or search your inbox, your client sends another request to the Gmail server and the server sends a response with the data you need. This back and forth communication handled in milliseconds is the essence of client-server architecture. Gmail is just one example. Reliable, fast, and always ready to respond. In this segment, we are going to understand how client-server architecture works. Let's understand that how client-server architecture actually works in stepwise fashion. Imagine you open your web browser and type in a website address. At that moment, your computer, known as the client, prepares a request for information, like asking to view a web page. This request is broken down into small digital packets and sent across the network. It travels to devices like switches, router until it reaches the server. When the server receives the request, it processes it. For example, if you have requested a web page, the server locates the web page file, HTML images, scripts, and prepares a response. That response is sent back across the same network path to your device. Once received, your web browser puts the data together and displays the complete web page on your screen. This request response cycle happens in milliseconds and is repeated every time you open a web page. The server handles multiple requests at once from different clients, ensuring everyone gets the right data quickly and efficiently. Now we are looking at the working of individual clients and the server in the client-server architecture setup. As you can see in the given diagram, the client, which is known as A, sends a packet to client B, then it goes down the wire to the server. The server, after receiving the packet, forwards it to the destination, which is client D in this case. Similarly, if client A wants to communicate with all computers or clients in the network, then the same procedure is followed. The server is even also responsible for forwarding packet from any client to the printer or any other device in this network setup. Now we are going to discuss advantages of client-server architecture. Now that we understand how network architecture works, let's talk about the advantages it brings, especially in the client-server setup. First off, centralized management. Since all the data and resources are stored on a central server, it becomes easy to manage user, files, backups, and security all from one place. It is like having a command center that controls the entire network. Second, we get better security. Because everything is controlled centrally, it is easier to monitor access, set permission, and protect sensitive information. If one client gets attacked, the receiver can isolate it without bringing down the whole system. Third, scalability. As your network grows, you can easily add more clients without disrupting existing services. Whether it is 10 users or 10,000, the structure stays stable and organized. Another big advantage is its flexibility. Since all the clients access the same server, everyone sees the same updated data, no duplicates, no confusion, just clean and synchronized information. And let's not forget about the interoperability. All the devices like printers, computers, internet, and applications are working together to achieve the same objective. In short, we can say client-server architecture is reliable, secure, and built for growth, making it the foundation for many modern networks from offices and schools to cloud systems and data centers. Since we all are aware about the fact that client-server architecture offers many benefits, but it is not free from certain disadvantages, let's look at some of the key disadvantages of client-server architecture. First, there is issue of server dependency. Since all the clients rely on central server, if that server crashes or goes offline, the entire network can come to a halt. No access, no data, no services. It is a single point of failure. Second, the cost can be a major concern. Setting up and maintaining a powerful server, secure connection, and backup systems can be expensive, especially for the small organization. Another drawback is maintenance complexity. Managing updates, security patches, backups, and user permission from central system requires skilled administrators. One wrong change can affect everyone. Next is the traffic congestion. When too many clients send requests at the same time, the server can get overloaded, causing delays or timeouts. This makes the performance heavily dependent on server capacity and bandwidth. And finally, limited autonomy of clients. Clients rely entirely on the server for most of services. If they are disconnected, they often cannot perform important tasks on their own. So, while the client-server networks are reliable, secure, they also demand robust infrastructure, careful planning, and continuous support. When we talk about how computers connect and share data, one simple and powerful model is the peer-to-peer network. It is also known as P2P network architecture. In a peer-to-peer network, there is no central server controlling everything. Instead, each device called a pair can both send and receive data. It is like a group of people in a circle where everyone can talk directly to anyone else without needing a leader or manager. All the devices have equal status in this kind of architecture. Similarly, all the devices have equal access and authority in the network. All the connected computers act like server and client at the same time. This same peer-to-peer concept is also used in blockchain technologies like Bitcoin, where each pair in the network holds a copy of the ledger and verifies transaction. A great example of P2P network is file sharing using torrents. When someone downloads a file using a torrent file, they are actually downloading small piece of file from many other other pairs, who already have those parts. At the same time, their computer also share pieces they have already downloaded with others. No single computer holds the entire file alone. It is shared across the whole network. This type of network can be implemented in any kind of operating system, such as Windows, Linux, Macintosh, etc. Due to the fact that it doesn't require any special arrangement. So in peer-to-peer network, every device plays an active role. It is a system built on sharing, direct communication and cooperation, powerful and simple all at the same time. Now we are going to understand how does the peer-to-peer network actually work. In peer-to-peer network, every computer or device is called pair, which acts both as a client and server at the same time. It means that every pair can request data from others and also provide data in return. Let's say you want to download a large video file using a torrent client. Instead of downloading the entire file from one server, your device connects to the multiple pairs who already have parts of that file. You download small pieces from each of them at the same time. As you receive those pieces, your device also starts sharing them with other pairs who are still downloading. So everyone helps each other by sharing what they have, and the file spreads quickly across the network. There is no need of central coordinator. Pairs find each other, exchange information, and keep everything running. The same process works for other applications too, like sharing music or documents. Now we are looking forward to discuss the different advantages of peer-to-peer network. Let's talk about why peer-to-peer networks are still widely used in center environments, because they offer some great advantages. First off, they are simple and cost-effective. There is no need to invest in client server. Just connect to the computer and you are good to go. This makes point-to-point network perfect for small offices, classroom, or home setups. Second, easy setup and maintenance. Since each device manages its own resources, there is no complex configuration needed. Even user with basic knowledge can create a working network. Direct file sharing is another advantage of P2P network. User can easily share files, folders, printers without going through central server. This makes collaboration fast and convenient. Another advantage is no central point of failure. If one computer shuts down, the rest of the network can still function. Unlike a client-server setup, the network doesn't rely on single machine. So whether it is sharing files, collaborating on documents, or playing multiplayer games, peer-to-peer network offers a lightweight and efficient way to connect. In the last segment of this video, we are going to discuss what are the different disadvantages of peer-to-peer network. While peer-to-peer networks are simple and cost-effective, they do come with few important limitations which are required to be understood. The main limitation is lack of central point for storing files and resources. If there is no central backup system, if pair crashes or deletes files, there is no guarantee anyone else has a copy. A regular manual backup becomes necessary, which is not always practical. Secondly, security is a major concern since there is no central server to monitor and control access. It is easier for unauthorized user or malware to spread across the network, especially if devices are not properly protected. Third, data is harder to manage. Files are stored on individual computers, not in the central location. This can lead to duplication, outdated versions, or even lost data if one device goes offline. Fourth limitation is performance. Performance can vary since all pairs share their own resources. The network depends on speed and reliability of each individual device. If one pair is slow or overloaded, it can affect everyone else. And finally, scalability is limited. P2P network work well for small groups, but as more devices are added, things can become more messy and harder to control. So, peer-to-peer networks offer simplicity. They are best suited for small setup where advanced control and security are not crucial. Thanks for watching this video. If you guys are having any questions, then you can drop in the comment section.